What's up, future civil engineers? How you doing? I'm your instructor, Daryl J. Mendros Balbin. In this video, I will solve sample problems 1 to 3 in head losses in pipes. Determine the friction factor from the given data. Reynolds number is 20,000, diameter is 50 millimeters, and absolute roughness is 0.5 millimeter. The Reynolds number is greater than 4,000. Therefore, the flow is turbulent. So we will be using the Colebrook equation, which is 1 over square root of f is equal to negative 2 logarithm of the quantity E over D all over 3.7 plus 2.51 all over RE times square root of f. Substituting the values given in the problem, E is equal to 0.5 millimeter, D is equal to 50 millimeters, and the Reynolds number is 20,000. So cancel millimeters, and solving for F, the friction factor is equal to 0.0407. Final answer. A 100-meter long pipe with a diameter of 50.8 millimeters has a water moving at a speed of 2 meters per second. If the frictional factor is 0.028, calculate the frictional head loss on the pipe in watts. We need to solve for power in watts. And power is equal to gamma QH. First, we need to solve for H, wherein H is the frictional head loss. And since we're given a frictional factor, we will be using the Darcy Wasteback formula, which is HF is equal to FLD times V squared over 2G. Now, substituting the values given in the problem, the frictional factor is 0.028, the length is 100 meters, the diameter is 0.0508 meter, the velocity squared is 2 meters per second squared, and G is 9.81 meters per square second. Now let's try to cancel the units. So the meter will be cancelled. This will become meters squared per second squared. So cancel second squared, cancel meter, this just becomes meter raised to 1. Therefore, HF is in terms of meters. That is equal to 11.24 meters. Next, we solve for Q, or the flow rate, which is equal to AV. A is the area of the circle, which is pi fourths d squared. And our d, or diameter, is 0.0508 meters. Multiply that with the velocity 2 meters per second, we get the flow rate equal to 0.00405 cubic meter per second. Now we're ready to solve for power. Substituting now, the gamma of water is 9,810 newtons per cubic meter. Our Q is 0.00405 cubic meter per second, and our H, the frictional head loss, is 11.24 meters. And the resulting unit of our power is in terms of watts. Solving for power, that is equal to 446.57 watts. Final answer. Water flows through a 200 millimeter diameter of stainless steel pipe at a rate of 0.126 cubic meter per second. Determine the head loss over the 40-meter long section of the pipe in kilowatts. Use N equal to 0.015. Power is equal to gamma QH. Solving first for H, or the head loss, since we are given a roughness coefficient N, we will be using the Manning formula when Q, or flow rate, is given. And Q should be in cubic meter per second. That is, HF is equal to 10.29 N squared LQ squared over D raised to 16 over 3. Substituting the values given in the problem, the N is 0.015, the length is 40 meters, the flow rate is 0.126 cubic meter per second, the diameter is 0.2 meter. Solving for HF, that is equal to 7.86 meters. Now we're ready to solve for power, wherein the gamma of water is 9.81 kilonewtons per cubic meter, the flow rate is 0.126 cubic meter per second, and the head loss is 7.86 meters. The resulting unit of the power is in kilowatts, and that is equal to 9.72 kilowatts. Final answer.